This is practice quiz 6, problem 5C, and I'm going to start reading the problem, and as I read it, I will highlight what I need from each of these sentences. The average weekly pay rate for employees at a financial firm is 4,000 with a standard deviation of 1,000. So here we're told about a population. And this population has a mu of 4,000 and a standard deviation of 1,000. And then continuing here, using the criteria from the central limit theorem, create a distribution of sample means for the following situation if we randomly selected 100 employees. So we want to know what a distribution would look like if we had n equals 100 employees. And it says here we're going to use the central limit theorem, and I'm going to write the three principles of the central limit theorem. The first one here says that the shape of my distribution will be a bell curve, if it meets one of the following criteria: if the population is normal, or if my n is greater than or equal to 30. Since in the problem down here we did not see that the population was normal, we have to rely on b then and look at our n, which is in fact greater than 30. So I'm going to go ahead and draw a bell curve here. My second characteristic says that the mean will equal the mu. Whatever my population mu, which is over here, that's what my mean is going to be. So for this bell curve, as I go down this, my mu, or my mean, is going to be 4,000. And finally, my standard error is going to be my standard deviation of the population divided by the square root of n. Okay, so applying this equation here, I'm going to take 1,000, which is my standard deviation of the population, and divided by the square root of 100. This here should give you 100. And so 100 is my standard error. So I move the text so that we would have more space, and I'm going to go ahead and go up one standard error this way. And since my standard error is 100, I now land on 4,100. And if I go another standard error, I should land on 4,200. If I go one standard error below, I land on 3,900. Another standard error, 3,800. So this here is my distribution of sample means if my n equals 100. So now I cleared most of what we just did to move on to problem D. And problem D says use the distribution of sample means for 100 employees from above, which is what we just completed, and find the probability of obtaining a mean of 4,200 or higher. Now looking at this graph, we already have 4,200 or higher, and so converting that into a z-score, that should give me a z-score of plus, that should give me a z-score of +2. Just because at that point I know that I'm going up 2 standard errors. However, I'll go ahead and solve it using our z-score equation, which is m minus mu over the standard error. We know that my m, we're looking at 4,200 minus 4,000, which is the mu, over the standard error, and we found that to be 100. So at the top, we're left with 200, the bottom 100, and this is plus 2. Now, to find the probability of obtaining a mean of 4,200 or a z-score of 2 or higher is I'm going to shade from this point to, I shade it to the closest tail. So I know I'm going to have to use column C. And if I use column C, I can look up the z-score 2 under A and cross-reference to what it says in column C. In column C says 0.0228, which comes out to be 2.28%. Additionally, if, as we've been talking about, that 2 standard deviations above would be an estimate of 2.5%. That's just a number we've been using. So in this case, I would accept either answer.